All right, I want to continue our discussion of dplyr, covering group by and summarize, which is some of the great, I guess, unleashes the power, in my opinion, of dplyr. Okay, so summarise is spelled with a S. This is Hadley Wickham, the author of the Tidyverse, comes from New Zealand. That's how they spell summarise. Later, they added summarise with a Z. It had the exact same functionality. I'm accustomed to using the original function with the S, so I continue to type it out that way. It's not wrong to use it with the Z, though. Okay, so when you call summarise, it will calculate summary values. So summary functions are things that take multiple values and reduce them to 1. So you have a set of 100 values. You ask for the mean, you get 1 mean. You ask for the median, you get 1 median. You ask for the variance, you get 1 variance. Okay? And so these are some examples, and what we're going to do is we're going to take the entire data frame, okay? The entire data frame of Star Wars, and I forget how many characters there were. Let me, where did it go? Under select and filter, how many were in the original? Okay, 87 rows. Okay, with 87 rows, it boils them all down to 1. Oh, it was right here in count. 87 rows, it boils them down to 1, and it seems a little bit silly that we would go through the trouble of writing all of this when I can just ask dplyr, or not even dplyr, I can just ask R, take the column height and calculate the mean, right? I could just do Star Wars $height and then throw that into mean, okay? And I have to do na.rm equals true, because if there's a missing value in the column, then the entire mean becomes missing. So we're just going to say ignore the missing values, na.rm equals true, and do that. Okay, so the way it works is you do Star Wars, select, filter, whatever you want to do to get the rows that you want or columns that you want. And here I'm going to just say summarize. All right, and then I specify basically columns that I want. So the column I want is average height. So I'm going to do average height. That's going to be mean of height. Variance of height, var height. I'm going to call var on height. Average mass, mean mass, minimum height, maximum mass, and then another summary function is the count of values that got summarized, 87. And so it calculates all of these things. Again, dplyr has a tendency, or tibbles have a tendency to kind of just display only a few significant figures. There are likely many decimal points after this. They're just kind of hidden from view, but they do exist if you kind of extract it out. So summarize does that, and it kind of boils it down to 1 row. Fine, but the power of summarize is really unleashed when you pair it with the function group by. Okay, with group by, it forms group based on a categorical variable. So here I have a categorical variable called species, okay? And we have things like humans and droids, and then, Chewbacca is a Wookiee, and what other species are there? I don't know, Gungans, and different species in the universe, and we can form groups for each species. After we form the groups, we can then select the columns or whatever we want, and this doesn't look all that different than if I just did Star Wars select, right? I just said, select the name, height, mass, species, and we get that. There's only a subtle difference, and it just says groups, species, 38, meaning there are 38 unique species in our data set, and it has established groups on that. But we haven't really asked dplyr to do anything with those groups, so it just kind of has that group information. It's kind of just like putting a little, star next to each of these, the grouping variable here, species. Okay. But now, if I call group by with summarize, okay, I'm going to say Star Wars, basically it's very much similar to this thing, this command, but I've thrown in a group by. Okay, so I said group by species, select these columns, and then summarize them. So we're going to say summarize. We want the mean height, standard deviation of height, mean of mass, standard deviation of mass, and the count. Then we get all of these things. Okay, so here, because we had 38 unique species, as indicated here by group species, we're going to get 38 rows, one row for each group. Okay, so we have one row for each group, and so there is an Alina species, and there was only one individual, so its mean is 79, mean height was 79, and its mean mass is 15, but no standard deviation because there's only one individual. Okay, we have 6 droids in our data set. The mean height of the 6 droids is 131. The standard deviation of the height is 49.1. Mean mass and standard deviation of the mass is this. We have 3 Gungans in our data set, and this is their mean and standard deviation, and so on and so forth. So we are getting the results where it has calculated these summary values for each of our different groups. Okay. Now we might look at that and say, you know what? It's not really useful to calculate the mean or the standard deviation when I only have a count of 1. So I can take this entire table, and so I've got Star Wars group by, select, summarize, and these are these things. And then I'm going to add a further couple operations. I'm going to pipe those results, so this previous table, I'm going to say filter to where count is greater than 1. So we're going to have this table. We're going to just filter to only where the count is greater than 1. And then I'm going to arrange them in descending order by count. And then I'll just ask for the first 6 rows. So here we have humans. There are 35 humans in our data set. Mean, standard deviation, mean, standard deviation there. We have 6 droids. This is their mean and standard deviation. We have 4 of unknown species, okay, and this is their mean and standard deviation. 3 Gungans, 2 Kaminoans, 2 Mirialans, and this is their information. So here it has done the summary things, but it has applied them to groups, and we get 1 row for each group in our summary table. You can also do group by and mutate, and when you calculate the mutate, it's going to do the calculations by group. So here I'm going to say let's just filter to humans and droids. Okay, so filter species is either human and droid, or species is unknown. Okay, and then I said select the name, species, and height. Name, species, and height. Group by the species. And then I want it to calculate z-scores for height. And we're going to add that. And so what this is going to do is it's going to calculate height minus the mean height divided by the standard deviation of height. Okay? So height minus the mean divided by the standard deviations, that's how we calculate a z-score. But because I've applied group by, it's going to calculate the mean of height for each species and the standard deviation of height for each species. So notice here, Luke Skywalker has a height of 172, but his z-score for height is negative 0.498. C-3PO is a droid with a shorter height of 167, but has a positive z-score, okay? And that is because if I go to the previous slide, the mean height for humans is 178, and the mean height for droids is 131. The standard deviation of height for humans is 12, the standard deviation of heights for droids is 49. So when we look at Luke Skywalker, he is below average, okay, below the mean for the humans, right? His height is 172. The average height of humans is 178. So he has a z-score that's negative. C-3PO, the average height of droids is 131. C-3PO is above the average height of droids. So he has a positive z-score. And so So these z-scores for height are calculated by group. Okay, so we have two groups of species, and when we said calculate z-scores and things, and we have means and standard deviations, it does it by group. Okay, if I get rid of this one line, group by species, okay, all I do is I just comment it out, right? So this is one nice thing about using pipes and putting each operation on its own line, is you can kind of comment out just one operation at a time if you want to. So it's the exact same thing, and I just comment out that one line. Here, I get rid of group by species, and now it's comparing everybody on the same scale. And so Luke Skywalker has a height of 172, which is, I guess, ever so slightly above average. C-3PO has a height of 167, which is a little bit below average, and so we get a z-score of negative 0.18 for C-3PO. Okay. You can continue to apply multiple group bys. So here's some toy data. We have countries: Afghanistan, Brazil, China, ABC. We have years: 1999, 2000. We have sex, female and male, and at least in this data set, in cases 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. So just some toy data just to kind of illustrate how kind of group by can work here. You can have multiple values or multiple variables in the group by. So we're going to take this, and I'm going to first group by country and year, and we're going to just take the total sum of the cases. So if I group by country and year, okay, we're going to get Afghanistan 99, Afghanistan 2000. There were a total of 2 cases in Afghanistan 99. Basically, it just added the 1 and the 1. In Afghanistan 2000, it added the 1 and the 1. Brazil 99, Brazil 2000 gets 4, 4. China 99, China 2000, 6 and 6. I can call summarise again, okay? So here it's grouped by country and year. If I call summarise again, it's going to just group by the country, the first order of groups, okay? So then we get the sum there: Afghanistan, Brazil, and China. And then if I call summarise again on that, then it just gives me the total, 24, okay? So the first thing we have, when we first do group by country and year, we have 6 groups, and that's why we get 6 rows. But within this, we have 3 subgroups by country: Afghanistan, Brazil, China, and we get that. And then if I call summarise, I get that. No more groups. If I call summarise one more time, I get a summary of 24. Here, if I change the order of the multiple groups, I'm going to group by year, then country. Notice what happens. I get year, then country. I still have a total of 6 groups. Okay? 1999 Afghanistan, 99 Brazil, 99 China, 2000 Afghanistan, 2000 Brazil, 2000 China. You can see by grouping by year first, then country, year gets priority, so it sorts by 99 first, then 2000, and then it sorts by country. How many subgroups do we have here? It gives us information. It says there's 2 groups by year. So if I call summarise on this table, then we get 2 groups, 1999 and 2000, 12 and 12. And then if I call summarise one more time, I get 24 in total. So, so you can do group by, you can group by multiple variables, and it will, figure out how many kind of unique groups it needs to do, and it will also keep the hierarchy as well. If you can get a handle of group by and summarise in dplyr, there is quite a bit that you can do. So you'll have some exercises in homework number 3 that challenges you to do some grouping, group bys and summarises there.